And Braun.
Alright, this is a quick and dirty test of the analog to digital converter on the X-Mega microcontroller. So we'll be feeding a 1 kilohertz sine wave to it, so it'll be nice and slow, and then reading back the values over UART. So we'll get to see both UART and the ADC in action in this test. So first, since our ADC right now has a 1 volt internal reference, we're going to create a sine wave between 0 and 1 volt, roughly, a little bit less, and offset by half a volt. It's AC coupled right now, so you can't see it, but the maximum is just under a volt, the minimum is just over 0, peak to peak is almost 9/10 of a volt, and right now it is too fast. Now it's almost exactly 1 kilohertz in frequency. Okay, so with that, we will hook up the positive terminal to port A pin 2, which is the ADC input. We don't need the scope anymore. And black one to ground. And we have the same diagnostic program we've been using in the last couple of tests, set up this time around to simply start an ADC conversion, spin in place, waiting for the ADC conversion to complete, then store the result, perform an integer to ASCII conversion on that result, which is, as a side note, a very costly operation in terms of time, so this is not really a proper ADC full-speed test. But after that's complete, we will write it back over UART to the terminal, where we should see an ASCII number come out, which should be between 0 and 255. If we program this, there we go, AVR dude reports no errors, and we're going to quit and access the UART, which is over, which is in /dev/tty USB 0. So we're going to let Minicom set that up for us. USB TTY 0, there it is, at 1 megabaud. And it'll initialize. That's done. And you can see on the right-hand side here, Minicom is spitting out numerical values. It's not printing carriage returns, so Minicom is a little confused and pegs them against the side of the screen. But that's okay, we don't really care about Minicom. We just used it to set up the serial terminal. So I'm going to quit, and then we're going to cat /dev/tty USB 0 and put that in a text file. We'll call it ADC capture 2.txt. And we'll let that run for a few seconds. Note while it's running, the transmit light here on the UART is on, and when I stop the command, it turns off. So transfer stops, and now if we go look at ADC capture 2.txt, what we see are values ranging between 255 and about 45. And they go up and down and up and down, up and down, back and forth in the shape of a sine wave. So this is a 1 kilohertz sine wave, and we're getting, if we look at the peak of one of these at 255, we're getting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 samples per 1 kilohertz per period on this 1 kilohertz wave. So it's definitely not up to speed yet, but we're able to at least see values being outputted. And if we want, we can display them in real time, and here they go. They just spit out on the terminal quite quickly. So in any case, this means that UART is working, and if we take the function generator off, you see here they drop down to roughly 30, 33, where the pin is floating. And that's it.